Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Decarboxylation, loss of CO2, occurs most readily when a carboxylic acid has a carbonyl group, C is equal to O, at the beta position, 2 carbons away, i.e., the beta-keto acid arrangement. This allows a cyclic 6-membered, or in simple cases 4-membered, transition state where the beta-carbonyl assists in removing CO2 via a concerted mechanism. Moving on to the next step. For easy decarboxylation, we need the pattern C is equal to O CH2 or C is equal to O CHR, where the carbonyl is directly beta to the carboxyl group. Moving on to the next step. PHC is equal to O CH2 The ketone is gamma to the carboxyl. There are 2 CH2 groups between C is equal to O and Q. This is a gamma-keto acid, not a beta-keto acid. Decarboxylation is not as facile. And for the final step, OC is equal to O CH pH CH2C is equal to O at. The carboxyl carbon is C1. The alpha carbon bears pH, then CH2, then C is equal to O. The carbonyl is at the gamma position relative to the carboxyl. Not a true beta-keto acid. This is a diacid-like compound with a benzene ring linker meta hook C6H4CH2 3Q. No beta-keto arrangement, decarboxylation would require very harsh conditions. OC is equal to O CH pH CH2C is equal to O CH2CH3. Here C1 is equal to Q, C2 is equal to CH, pH, alpha, C3 is equal to CH2, C4 is equal to C is equal to O, ketone. Wait, re-examining the structure, the carboxyl is at one end, and looking at the drawing, the carbonyl, C is equal to O, appears to be directly at the beta carbon, C3 position from Q. Actually from the image, option D shows PHCH, Q CH2 co-et, meaning the keto group is beta to the carboxyl, hook CHPH CH2 co-et. The beta carbon to Q is CHPH, alpha, and the next carbon bears the ketone. This is a beta-keto acid. The carbonyl is on the beta carbon counting from the carboxyl. This arrangement, CoCHRQ, most readily loses CO2. Both appear similar, but in option D, the carbonyl is at the beta position directly. C is equal to O is on C3, which is beta to the carboxyl carbon C1, with C2 being alpha carbon bearing pH. In option B, the arrangement places the ketone further away. Option D has the classic beta-keto acid pattern, ArCO-CHPHQ, which forms a stable enol after decarboxylation and proceeds through a favorable transition state. Option D is a beta-keto acid, ketone at beta position relative to carboxylic acid at CH2CHPH, where the keto is beta, enabling the well-known facile thermal decarboxylation via a cyclic transition state, releasing CO2 and forming a ketone. The phenyl group at alpha provides additional stabilization. This makes D the most readily decarboxylated compound. Therefore, the correct answer is D. Therefore, the correct answer is option D.